Hello student, how are you? I am Arun sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel, Tuition Expert. I'll teach you the vector. There are 12 class in vector. Just follow my class and you need not any tutor. You must qualify the IIT or NEET. Let's start the vector class. The quantity, there are three quantity: scalar, vector and tensor. Okay, scalar quantity which has only magnitude. It need not any direction. Example: mass, volume, etc. Vector, it need the magnitude, both magnitude and direction. It has both magnitude and direction. And tensor, the quantity which neither be treated as scalar or vector is tensor. Neither scalar or vector. Here example is vector displacement. Displacement is the shortest distance. It needs a direction. Velocity, it needs a direction. Tensor, example, moment of inertia. This term will be discussed later. Moment of inertia. So there are three quantity. Now what is the why direction is important to mention a vector? Just follow. Suppose here is a block of mass 10 kg. Here is a block of mass 10 kg. A force is directed, 20 Newton force act along the horizontal direction, and same mass and same force is directed at an angle 60 degrees horizontal. Now what here mass is same, force is same, but this is directed along horizontal, this is directed at an angle 60 degrees with horizontal. So what is the acceleration here? Acceleration equal to force by mass, and here acceleration, the body moves along the horizontal, so here effective force will be component of this force 20 cos 60 degree, that is 10 Newton. Here only 10 Newton force is acts on the body, so here acceleration equal to force by mass, that is 1 meter per second square. So the same mass same force, but direction is different, the direction of force is different, so effect will be different. So that's why direction is very important to mention a vector. The representation of vector is represented by letter and a arrow over the top of the letter. This is representation of vector. Representation of vector. And graphical representation. Graphical representation. The vector is a line segment. What is vector? A vector is a line segment. Suppose a line segment, here a initial point and a final point. 2 points required. Where the vector start, this is initial point, and where the vector end, this is final point. The arrow is always added at the end points or final points. Now this is the representation of vector. Graphical representation. The length of the line segment is the magnitude of the vector. Magnitude of the vector is the magnitude. That is the length of the line segment, and it is denoted by two vertical line. So this is the magnitude of vector AB, and we need a direction. Here the direction is A to B. Direction is A to B. We need a direction. The direction is denoted by unit vector. Very very important. Cap. AB over cap. This is unit vector. Unit vector means whose magnitude is unity. Unit vector along AB. Unit vector along AB. Its magnitude is equal to 1. So what is the significance of unit vector? The unit vector provides only direction. Unit vector provides only direction. It does not provide any magnitude. It provides only direction. So vector is magnitude and direction. Now what is vector AB? Vector AB equal to, it has magnitude and direction. This is magnitude. This is magnitude. And this is direction. Very, very important. Direction. Direction is very important. Magnitude and direction both to be required to mention a vector. So, function of unit vector is only to provide the direction. So, AB equal to vector divided by its magnitude. So, this is very, very important. Unit vector AB equal to vector divided by magnitude. If we denote by single letter, so unit vector equal to vector A divided by its magnitude. That is, or this we can write A vector equal to A into A cap. This is magnitude of vector A, and this is direction. This is direction along A. So very, very important, magnitude and direction. What is the condition to be a, what is the condition of a quantity to be a vector? Condition of a quantity to be a vector. A quantity has both magnitude and direction, but it may not be vector. Example, current. Current, it has both magnitude and direction, but it is not a vector. So if a quantity has magnitude and direction, it may not be vector. So what is the condition of a quantity to be a vector? Condition is that it must follow. Condition is that a quantity must follow the law of addition of vectors, that is triangle rule, and also commutative rule. Suppose a vector A and another vector B, if this is satisfied, this property is called commutative law of vectors. If this is satisfied, then we can say that this is a vector quantity, and vector must follow the law of addition of vectors, that is triangle rule, parallelogram rule, etc. First vector is equal vector. Equal vector. Equal vector means it has both magnitude and direction, both equal. Equal magnitude and direction. Suppose this is A vector, this is B vector. You see that obviously A and B magnitude equal, and this vector also direction are also equal. Direction is denoted by cap vector. Direction also equal. So magnitude and direction both equal. So now we can say that A equal to B. If two conditions must satisfy, then we can say that A equal to B. Suppose one condition is satisfied, another is not satisfied. Suppose I draw the figure. Suppose this is A and this is B. Suppose A is inclined. Here A and this is B. Here both magnitude equal, but not equal to B. So that's why we can say A not equal to B. Okay, here a magnitude equal but direction is not equal, so a not equal to b. Opposite vector or negative vector, opposite of vector or negative vector. Suppose this is a, here direction is just opposite, magnitude equal, magnitude equal, direction is just opposite, so it is called opposite vector or negative of a vector a. Direction is just reverse 180 degree. Collinear vector, collinear vectors. The vectors, this is called also parallel vectors. Parallel vectors. Suppose this is A, this is B, A, B, C. So these are called collinear vector because it is parallel. Now condition for collinear, condition key. What is condition? Now A equal to M B, A equal to M B. For M is any scalar, M is any scalar quantity. It may be positive or negative, positive or negative, positive or negative. Suppose A is double of B, so we can write here M is 2. A is 3 by 2 times, 3 by 2 times, so we can write M equal to 3 by 2. C is just opposite of A, we can write C equal to minus A. Here M is 1, minus 1. So M is any scalar quantity, it may be positive or negative. So condition of collinear vector is A equal to MB. Two vector will be collinear if A equal to MB, where M is any scalar quantity. So collinear vector. Next, position vector. Position vector. We know that vector must need 2 points, one initial point and another is final point. So for position vector, initial point will be origin. Initial point will be origin. O is origin. This is called also fixed vector or localized vector. Position vector is one point is fixed origin. OA vector, O is origin. OA vector is called position vector PV. Position vector is PV. Position vector of point A. Similarly, OB equal to position vector of point B. That is initial point is fixed. Co-initial vector. Co-initial vector. Initial point is same. Initial point suppose A, B, A, C, A, D. There is not A may not be origin. Co-initial vector A, B, A, C, A, D are co-initial because the initial point are same of this vector. Co-initial vector. Co-terminal. Terminal is same. Co-terminal vector. Suppose here terminal point is same, that is S. PS, QS, RS. These are terminal point, terminal vector because the terminal point of this vector are same. Now null vector or zero vector. This is important. Null vector or zero vector whose magnitude is 0. Magnitude is 0, but it has a direction. it has any direction. That is, direction is arbitrary. Direction is arbitrary. It takes any direction. Suppose a minus a. What can write with a minus a? A of a minus a, we can write a plus of minus a. So the magnitude, so here magnitude is equal, but it has a direction. So this is called null vector. Null direction of null vector may be arbitrary. It takes any direction. Suppose the direction of zero null vector is along a. Suppose b minus b equal to, we can write 0. Here direction of null vector is along b. Here the direction of this null vector is along a. So these vector, this and this are not two same vector. This is null vector, magnitude is 0, but its direction is along a and its direction is along b. And generally if we cross product, suppose a cross a equal to 0. Here it has a direction, a cross a equal to null vector. Here the direction of null vector is along the cross product which it takes. Angle between two vectors. Suppose this is a and this is b. This is a, this is b. Here we can easily say that angle between this is this angle. Suppose this is 60 degree. We can say that angle between a and b is 60 degree. Now suppose this is a and this is b. This is a, this is b. So what is the angle here? Suppose this angle is 60 degree. Here a, here b. The angle is 60 degree. This angle is 60 degree. Now here what is the angle between a and b? The angle between a and b will be in this direction. So b must be shifted. To determine the angle between two vectors, we must be coinitial or coterminal. That is, b can be shifted like this way. This co-initial point, initial point will be same. So b can be this. So now this, if this angle is 60 degree, this angle is 120 degree, because 180 degree. Now we can say that angle between a and b is 120 degree. Angle between a and b is 120 degree. So end to end and tail to tail. Then we can determine the angle between a and b. Two ends must be same for two vector and two tail must be same for two vector. Then we can determine the angle between two vectors. Suppose this is vector a and this is vector b. This is x-axis, this is y-axis. Now this angle is 60 degree. Suppose this is vector a, this is vector b. Now this angle is 60 degree. What is the angle between a and b here? Here initial point is this and here terminal point is this. So we must, this is b. So this is 60 degree. Now this angle is 120 degree. Now the angle between a and b will be 120 degree. So initial point must be same to determine the angle between two vectors. Terminal point also same. This is 60 degree. Now what is the angle between a and b? Here we can say that angle is between a and b is 60 degree because two terminal point will be same. So angle is 60 degree. And if we extended this vector, suppose this is b and this is a, this is a. So here also angle is 60 degree because vertical opposite. So we can say that angle between a and b is 60 degree because here two terminal points of two vectors will be same. Terminal point of two vectors will be same. That's why we can say that angle between a and b is 60 degree. This is for class 1. Just follow my classes and you must qualify the IIT JEE or NEET. different problems related to IIT and NEET will be discussed later. Just first follow the theory and the problems will be solved later. Okay, thank you.